So this gives you an idea of how the greenhouse effect modulates the temperature at the surface of the Earth. Now, we'll consider a couple of cases. The question is, what is emissivity? Well, for the modern climate, it's been found that epsilon is about 0.78. If you plug that into your equation, you'll find that Ts is roughly 1.13 times Te, which corresponds to 288.3 Kelvin. In a hotter climate, and I'm using a bright red color here, say if we double CO2, this corresponds to a radiative forcing change of about 4 watts per meter squared. And it changes the emissivity or the absorptance of the atmosphere by about 0.02. That means that the emissivity for a doubling of CO2 is about 0.8. So if we doubled CO2, Ts would become 289.5 Kelvin. So a global warming signal of about 1.2 Kelvin. And the question is this going to be our future climate? And unfortunately, this is not the whole story, because it's so simplified and we're ignoring a whole bunch of feedbacks in the climate system. For example, the warmer your atmosphere, the more moist it becomes, and it can absorb more energy and will lead to the clouds and other effects will lead to additional heating. With feedbacks, we are estimating that a doubling of CO2 will actually lead to about a change of delta epsilon of about 0.04, which gives you a global warming of about 2.4 Kelvin. This is from just very idealized modeling considerations. If you run a fully resolving, very complicated global climate model that accounts for all the effects that come with increasing greenhouse gases, the IPCC, which is the International Panel of Climate Change, and which represents the consensus of scientific findings in this regard, which predicts that a change of the surface temperature for a doubling of CO2 is about 3 Kelvin, as I mentioned earlier.